So we are not going to do the warm-up today. I will leave it for us to do another time. Instead, we're going to jump into the lesson, which is section 6.3, volumes by shells. Volumes by shells. So I'm going to give you a little background. Shell method for calculating volume is not a required topic by the college. Oh, it's dark in here. I'm going to turn the lights on.
We didn't like it like that.
Yeah, I know it makes you sleepy when lights are on. Hasn't it like a nice ambiance? Yes. Mood lighting. All right, so 6.3. So all that being said, volume by shell is not an AP topic. However, we teach it every year for one reason and one reason only, in that it makes a lot of volume problems much easier. So it is a method that is totally allowed. Like the College Board, believe it or not, they know shell method and they accept shell method. They just don't require shell method, right? So anyway, so you're not required to learn shell method. However, it's going to make your life so much easier. Once we get into doing a whole bunch of different types of volumes, being able to do them with shell method, you're going to be like, wow, this really is like way easier. So anyway, so that's why we teach it and continue to teach it, is because it really does make your life a lot easier for some of the volumes. All right. So here's the point. There's nothing to write on here, so just kind of watch for a second. So suppose we have this blue region that is bounded by y equals 2x squared minus x cubed and the x-axis. If we were to spin this about the x-axis, what method would we use? Close. Disk. And would it be a dx or a dy? Dx, because horizontal axis, right? If we were to spin this about the y-axis, what method would we use? Washer, because you got space, right? Would it be a dx or a dy? Dy. So here's the problem. If we spin it about the y-axis, where it has to be a dy, that means we have to solve this for x.
Yeah.
Right? Okay, the only way to solve this for x is to use what's called the cubic formula. It's kind of like the quadratic formula, but for cubics, right? So anyway, which I have learned years ago, but have long since forgotten. So anyway, and I'm sure you guys do not know it. Or does anyone know it? Okay. So anyway, it's the only way to do it. So it can be done, but it's really hard. So correct. We're going about the y-axis, washer method. Y-axis is a vertical axis, which means it's a dy, which means your functions have to all be in terms of y's. So you need x equals stuff in terms of y's. Okay. All right. So what do we do? Well, this is where, don't write yet. This is where shell method comes in. So shell method, so pretend this is like that same blue region, all right? That we're revolving. It's not exactly the same blue region, but just like pretend. All right. So if this is that blue region, what we do is we split it this way. Normally we'd split it this way into washers, but this time we're splitting it this way. And a shell is basically like the surface area of a cylinder with a little bit of thickness. That's what they're calling a shell. So kind of like an artillery shell, right? They call that a shell. I don't know if you know what that is. Anyway, but a shell in this context is like the outer part of a cylinder with a little bit of thickness. So they're kind of showing you how you take they're just giving you like an inside view. Yeah, now they're closing them all up so you can see what it really looks like. So you kind of split it into shells, you add all these volumes of these shells together, and now it's going to show you what the actual region looks like. And then you get this beautiful thing, which I think looks like a butt cake. All right. All right. Okay. So anyway, so that's shell. Now, so here's the thing. In order to use shell, so what we have to do is add the volumes of those shells together. Well, in order to find the volume of the shell, you need the surface area of a traditional cylinder. So a traditional cylinder that you guys grew up with looks like this, right? Not the top and the bottom, just the outside part, right? So the area, the surface area of the outer part of a cylinder, well, if you take the cylinder and split it down, like just lengthwise, and open it up, you always get a rectangle, right? So a cylinder is really just a rectangle that's been folded around. So area of a rectangle is length times height. So what is this width of the rectangle? It's the same as the circumference of the circle, right? Okay, so what's circumference of a circle? 2 pi r. So the surface area of this cylinder is 2 pi r times the height h, 2 pi r h. So what we're doing is we're taking this surface area of the cylinders, right? Taking infinitely many of them, but giving them a little thickness. The thickness is the dx or the dy. That's your thickness, right? So because we want that thickness to approach 0 so that we can fit infinitely many of them into the space. So volume by shell is 2 pi rh dx or dy. And this you have to know. So 2 pi rh dx or dy. I'm pretty sure on your test there's at least one problem. I'm not positive. I might be lying, but I think there's one problem where we actually say use shell method. I'm not positive, but I think there's. If there isn't, you don't ever have to use shell if you can mathematically figure out how to solve the equation for x in terms of y. But anyway, so here's the magic part of shell. Oh, it just made me think of magic shell. Those of you who know what that is. Anyway, so anyone know? Magic shell, that's the chocolate stuff you put on ice cream and it hardens. It's called magic shell. Anyway, so here's the part of magic shell. If you have a vertical axis with shell, it's dx. And if you have a horizontal axis with shell, it's dy. Shell is the opposite of discs and washers. What's nice about this, if you think about it, if you have a horizontal axis, you can use disc or washer and be dx. If you have a vertical axis, you can use shell and still be dx. So you can always find all of your volumes in dx world, right? If you want to. So you use disc and washer when your axis is horizontal, use shell when your axis is vertical, and then you never have to solve for x in terms of y. So that's, yeah, I know. So that's why I like shell. I like it because, I don't know, because I'm lazy. Anyway, I like it because I like to have things with dx. So I will tell you, I should probably warn you, there is a way to write a problem to force you to do a dy. So there is a way to do it. It's not easy, but it can be done. The College Board has done it before. And it deals with having a function where if you were to do a regular top minus bottom, you don't have a correct top and a bottom where you have to do right minus left or you won't be able to get the boundaries of your region. So if we write a problem where, say, like the shape of our figure, whoa, whoop, again, whoa, just making it worse. You're making it worse. Okay. If we have some figure like that, and we're revolving this about the y-axis, you don't want to do this dx. It'd be like impossible. So, because there's no way to do like top minus bottom, because like you'd have little like spots in here all over the place with different tops and bottoms. But it's a clear right minus left. So we can force you to do a dy, but it doesn't happen very often, like very rare. I think I've seen it maybe once on an AP exam where they set up a function like that. So, or not a function, but a relation. All right, so the trickiest part of shell is finding the radius. And it's actually super easy. Like it's easier than, like, people want to make it more complicated. That's why it becomes tricky, is because everyone thinks the radius is harder than it is. The radius is actually really easy, but it takes getting used to. And then once you get used to it, you're like, okay, this is super easy. And then the height is very normal. It's what we've been doing all along. So what we're going to do is oh, you know what? Go ahead and write this down if you want to. It's just me adding more information about radius and height. So what we're going to do for our first example is we're not going to find any volumes at all. All we're going to do is learn how to find the radius and the height. And then once you learn how to find the radius and how to find the height, then you can do shell on your sleeve. You said you were tired. All right. Radius is always your axis minus the letter x, or x minus your axis. Or if for some crazy reason you're doing shell with a dy, which you could, then it's axis minus the letter y, or y minus your axis. Depends on what's on the right and what's on the left. Your height is just the boundaries of your region, like we've always done, top minus bottom or right minus left. The height is going to feel like what you've always been doing. The radius is the only thing that's new. Okay, so we're going to do this one. We're going to do it 6 times. So we have a region bounded by y equals x squared plus 2, that's this parabola, and y equals x plus 2, that's this line. So this is our region, our bounded region. I'll just write, this is y equals x plus 2, and this is y equals x squared plus 2. All we're going to find are the radii and the heights for a whole bunch of different axes. So the first one that we're going to do is we're going to revolve this about the y-axis. Now this is shell. So if we're revolving about the y-axis, would this be a dx or a dy? Dx. Vertical axis is dx in shell, right? So our axis, when we say the y-axis, this is really like x equals 0, right? It's the equation x equals 0. It's a vertical line through 0. All right. The radius is the radius of each individual cylinder shell, right? Cylindrical shell, we should call it. So there's infinitely many radii. Like the radius changes as you move through the function. But the radius, like if our shell, I'm just going to try to draw a little mini 3D image. So say we're at this x value, whatever this guy is right here, right? This distance that's 0. So if we're at some x value, this distance is x, right? This is also our radius of our shell, and our shell, right, is going around like that. That kind of makes sense. So you're finding like 2 pi RH will give you the surface area of this cylindrical shell. All right, so we need the radius of the shell and the height of the shell. The radius of the shell is the distance from the axis of rotation to the edge of the shell, right? Which would just be x. So here's how you know radius. So on the prior slide, I said radius, when we're dx, is going to be axis minus the letter x, or x minus the axis. How do you know which one it is? If your region is to the right of the axis, think of like this being x, then it's x minus axis. If your region's to the left of the axis, then it's axis minus x. But it's always axis and the letter x when you're in dx. So in this case, it's x minus axis, so our radius is x minus 0. Now your height is just top minus bottom, right? Top minus bottom with the boundaries. So your height would be x plus 2 minus x squared plus 2. So x plus 2 minus x squared plus 2. Yeah.
Isn't it right?
Yeah.
Did I put it wrong?
Yeah, you did the right one.
Ooh, these are backwards.
Oh.
Oh, I'm so sorry. It's still top minus bottom. Thank you for asking. That's kind of an important clarification.
That was special.
No, still top minus bottom.
This first hour, I think it's right minus.
No, these are correct.
Just the first hour.
Oh, this first hour thing. Well, we did like 50 of these. So if they do, and I know they don't because they all did like 50 problems. So they probably just didn't notice when they were writing this down, right? Okay. All right. Okay. Oh, thank you. I will fix my slides next time. All right. So on. Okay. So now we're going to go about the line x equals negative 3. So now, I'm going to delete this. Okay. So now I am revolving about a line, okay, not drawn to scale, because like this is 0, this is 1, so negative 3 would be like over here. But we're just going to pretend that it's like right here. So at x equals negative 3. So now we're revolving about this line. So now our cylinder, move this out of the way for a second. Our cylinder becomes this like big giant thing, right? Because we're revolving from an axis that's farther away. So again, but the axis is like the region still right of the axis. So what would be the radius? X plus 3. It's x minus negative 3. X minus negative 3 or x plus 3. Which makes sense that this is a bigger radius than this one because our axis is further away. What would be the height of our cylinder? It's just going to be the same, right? So I'm going to move this guy. Good. Move this back up. x plus 2 minus x squared plus 2. All right, exact same thing. Now we're going to revolve about the line x equals 20, which is over it's like way over here, right? So now, what would our radius be? 20 minus x. Oh, I'm sorry, Casper. Yes.
Yeah.
Okay, 20. Yes, that. 20 minus x, because now our region is left of the axis. So you got to do axis minus x instead of x minus x. Okay, what would the height be? It's still the same. All right. Do you have a question?
Yeah, when does it change to take the x minus 2 minus like the other way around?
When we have a horizontal axis. Funny, you should ask that. So now we're going to reverse everything, and we're going to revolve this thing horizontally. When you revolve horizontally using shell, it's dy. So now our radius is going to be with y's. Whoa. There we go. Okay, so now our radius is going to be with y's. So if we're, let's see, revolving about the x-axis, here's the x-axis, there's the region, the radius is to like whatever, here's our shell, pretend it's a really big shell that goes all the way down and all the way back up. So there's our radius. What's that distance? This is y, right? That distance is y. It's y minus 0. It's the letter y minus the axis, top minus bottom, so it's y minus 0. All right, we have to find the height. Now we have to do right minus left, which means we have to solve each of these equations for x in terms of y. So if y equals x plus 2, that's easy. X equals y minus 2. I give you 20 seconds in your groups to solve y equals x squared plus 2 for x. Go. All right, so x equals what? Square root of y minus 2. Where's the plus or minus?
It's all positive. The left side of it.
It's on the other side. So you get plus or minus y minus 2. Since all the x's are positive, we're in the first quadrant, then this is just positive root, right? If we were on the other side, it'd be the negative root. Okay, so just the positive root. So our height, right minus left, is root y minus 2 minus quantity y minus 2. Is that okay? Good. All right. So I want you guys to take 5 seconds and decide what the radius would be if we were to revolve this about the horizontal line y equals negative 3, which would be like way down here. Oh, wow, that was really quick. I should have just given you 5 seconds. Okay, so what's the radius? Y plus 3, right? Y minus negative 3, or y plus 3. What's the height? Yeah, it doesn't change. The height never changes, no matter what your axis is. The height has nothing to do with the axis. Well, except as far as like being horizontal or vertical, but like where it is doesn't make any difference. It's just the boundaries of the region that affect the height. Okay, what about if we revolve about the line y equals 20, which is like way up through the ceiling? 20 minus y. And then the height would be the same. Okay. Are you ready to put this together? Are you ready now? Now you're ready? Okay. All right. I'll give it. Hang on. People are still writing. Okay. All right. The first one we're going to do is the intro problem. So the intro problem was revolving the region bounded by y equals 2x squared minus x cubed and y equals 0 about the y-axis. So if we were to do washer, this would be crazy hard. But if we do shell, it's actually really easy. So we're going to do this with shell because with shell, would this be a dx or a dy? This would be a dx. Vertical axis with shell is dx. So with shell, you go 2 pi integral and then radius height with your, so I'll let you go ahead and go. Radius height dx. So first thing we got to figure out are the limits of the integral. Since it's dx, the limits would be x values, the x values of your bounded region, low to high. So what would they be? 0 to 2. Does everyone see how we got 0 to 2? Right? This is our region. The lowest x value of our region is over here. The highest x value of our region is over here, and they told us it was 2. Okay, I want you all to take a second now and figure out the radius and the height in your groups. Take a minute. Go.
This is like
What's the radius? X. So it's x minus 0. I'm going to write x minus 0, but you can just write x. That's fine. Just so you know, it's x and the axis, and it's right minus left. All right, height, top minus bottom. 2x squared minus x cubed minus 0, which you don't have to write the minus 0. I'm just putting it in so you know it's top minus bottom. Yes? Nope, they don't care. Good question. Other questions? Okay. So I have on the next slide, oh, wait, no, I don't. Okay, first, this is just me summarizing. You don't have to write this whole thing. This is just me talking about how do we know what to pick, right? You've learned now 4 types of volumes. You've learned disc, washer, shell, and cross-section. Disc, washer, and shell are used when you're revolving a function about an axis, right? Revolving or rotating. So if you see the word revolving or rotating, you know you're doing a disc, washer, or shell. If you see the words find the volume where the cross sections are isosceles, right? Triangles perpendicular to the y-axis, you know you're doing cross section, right? Cross section, there's no, it is what it is. You can't, there's no choices. You just have to do what it says. But all the rest you have kind of some choices a little bit. So personally, what I do is whenever I can, I integrate dx. So if I have a horizontal axis and no space between the axis of revolution and my surface, or my region, meaning that like the axis of revolution is one of my boundaries, like it's right there up against the region, then I'm doing disc. If I have a horizontal axis and there's space between the region and my axis, then I'm going to do washer. If I have a vertical axis, I'm going to do shell as much as I can, right? So that's just my personal preference. You don't have to do that. You can do a vertical axis with disc and washer just fine, as long as you can solve the functions for x, right? But if they're not solved for x for you and you don't feel like doing it, you can do shell. So anyway, all right, so that's just me kind of giving you a slide that talks about the 3 different rotational volumes that you've learned. All right. Okay. So, these were on whiteboards in first period, but I'm going to do a different whiteboard problem with you guys instead. So I want this one to be on paper. So what I want you to do is take a few minutes and see if you can just do the setups, all right? Just do the setups to find the volume of the solid formed by revolving the region. You can use a calculator if you want to see what it looks like. X minus 1 times x minus 3 squared and the x-axis. So there is a bounded region, a region bounded by that function in the x-axis. You're going to revolve it about the y-axis, and you're going to revolve it about x equals -4. So feel free to use your calculators and see if you can find setups, and I'm going to erase these on the board so that you can't see. So for the first one, when we're going about the y-axis, remember for all these you have a 2 pi. I already drew the region here, so we're going from 1 to 3. So if we're going about the y-axis, what's the radius? X minus 0 or just x. Yep. Height, top minus bottom of your boundaries, so the height would be the function. Yeah. So x minus 1 times x minus 3 squared, and then the whole thing's a dx. All right, did anyone put this in their calculator?
Yeah.
All right. Oh, I'm going to put equals because I'm going to give the exact answer first. All right. Who has an exact answer? All right, Casper, what'd you get?
24 pi over 5.
24/5 pi. All right. And then who has this as an approximate? 15.079 truncated, right?
Yeah.
All right. If you round it, it rounds to 15.080. All right, part B. So for this one, we're revolving about the line x equals -4, which is still a vertical axis, so we're still going to do shell. But now, what's our radius? X plus 4, x minus -4, or x plus 4. Height? Same height. So x minus 1, x minus 3 squared dx. And then, all right, Casper, what's the exact answer?
58.64306.
That is not an exact answer.
Okay, well.
Do you have it? All right.
232 over 15.
232 over 15 pi, which is approximately equal to
That
Four-
number,
should be 40.
48.6.
48.589 truncated, or 48.590 rounded. Is that okay?
That's great.
Okay.
I didn't plug something in correctly.
If you want, don't clear it. I'll come take a look.
Alright, so.
Okay. Yes.
I was gonna ask, how do you get the exact answer? My calculator
Oh, I
always
forgot
spits
for it.
like-
Don't put the pi in.
Okay.
Because if you put the pi in, pi cannot be converted to a fraction, right? So if you put the pi in, you're going to get a decimal. But if you don't put the pi in, then once your calculator gives you the decimal, just hit math, enter, enter, and it'll convert to a fraction. And you just stick pi next to it, right? So, but in all honesty, the College Board doesn't care. If exact or decimal, they're fine. They both are worth the same, right? But WebAssign wants exact. So if you want to cheat and save time on WebAssign, right?
Yeah.
Yeah.
Say that again.
So, if you feel like you really do need more practice with anti-differentiation, then you should do all these by hand. But if you feel like you got this, like you really do, if I had to sit there and multiply this all out and do this by hand, I could do it, right? Then why do it by hand? Just put it in the calculator. Yeah. Okay. All right. So before we move on to board work, it is Getting to Know You Tuesday. Keegan, pick a number between 1 and 32.
11.
First, on paper, see if you can get setups for these 4 problems. I'm going to give you a little bit of a head start. So, y equals 10 minus x squared is a graph that looks kind of like that. It's got both sides, but we're only going to be in the first quadrant, so I'm just going to draw this side. So y equals 0, that's the x-axis. X equals 1, x equals 5. 1 to 5. there's your space, your shape, your region. So this is y equals 10 over x squared. All right, you have 4 ways that you're revolving this. One about the x-axis, the y-axis, y equals 10 and x equals -3. I want you to set up all 4 of these, all dx. So all 4 of them with respect to x, no y's. All right, are we ready? Do you want to do it on paper first for a couple minutes and then transfer?
Yeah.
Yes. All right, so take a couple minutes, talk to each other, get this done on paper first, and then I want just the setups on your whiteboard. And actually, above each setup, I'd like you to write what method you use, disc, washer, or shell. All right? See first, because I want you to understand that it's not a sign of weakness to have the picture on your paper. You really do need to have the picture on your paper. Draw the sketch of the region, because when you have to do part C, someday, and it's not today. So part C, what method do you have to use? You have to do washer, right? So if you have not done washer a million times, which you haven't, right? This is the line y equals 10. How do you find big R and little r? Remember, it's volume equals pi integral 1 to 5 of big R squared minus little r squared. Okay, big R. You start with your pencil on the axis of revolution and draw a line to the farthest away function. That's big R. You can't do that if you don't have the picture on your paper, right? Okay. Start, like how can you do that, right? 10 minus 0, that's big R. Little r, start with your pencil on the axis of revolution, draw to the closer boundary, 10 minus 10 over x squared. That's little r, right? You can't draw those if you don't have the picture on your paper. I'm not trying to be mean to make you draw that picture every time. It really does help you. Sketch that region. All right, sketch that region. So, do you guys need another minute to finish?
No.
Part A was just about the x-axis. What method did you use? Disc. So for part A, disc is pi r squared. So when you're just doing disc, that means your radius is just the top minus bottom of your region. So for disc, it's just 10 over x squared minus 0. Top minus bottom. Okay. All right. For part B, you're revolving about the y-axis. What method are you going to have to do? Shell, right? Vertical axis. If we have to do dx, it's going to be a shell. So our volume is going to be 2 pi r h. All right. So we're revolving about the y-axis. Our region is to the right of the y-axis. What's the radius? Just x, or x minus 0. Height is top minus bottom, so it's 10 over x squared minus 0. How's that sitting?
That's sitting.
That's sitting?
It's sure sitting.
Is it sitting pretty or sitting like a chunk of coal? All right. The left, yes.
So how do you know when you use axis minus x or x minus axis?
For your radius?
Yeah.
So if the region is to the right, it's always right minus left.
Okay.
Think of the region as being your x. So then it's, if the region's to the right of the axis, it's x minus axis.
Okay.
If the region was over here to the left of the axis, it'd be axis minus x.
Oh, okay.
All right, good. Any other questions before we do part D? Part D, x equals -3. That's over here. So part D, is what method? Shell. I've lost you. All right, quiet down. 2 pi integral 1 to 5. Okay, we're revolving this region about x equals -3. What's the radius? X plus 3. X minus, I'm going to put minus -3, but you can write x plus 3. And then height is still minus bottom 10 over x squared minus 0. You don't have to write the minus 0. I'm just putting it so that people know.
I understand it.
You could, but if you do the other ones, the disc and washer shell, it's a dy, and it'd be a little bit more confusing. So, but you could, yes, do all of these that way. All right, there is one more little example, but we don't have time. So I will put this in the Smartboard notes. I might even record it for you after you leave. All right, for this problem, so we have y equals cosine x, and we have y equals x minus 2 squared, which I'm not drawing right. It actually hits after the cosine x, so let's try this again. All right, so there's our cosine x, and then x minus 2 squared actually looks kind of like that. They do intersect here. This is the point 0,4, but to find this point of intersection, you have to use your calculator, and I am going to quickly do this. 5, intersect, enter, 1 to 2. Okay, so we only need x values because we can do everything dx, so this is at x equals, well, approximately equal to 1.51097. Okay, so for part A, just doing some setups, we would have, if we're revolving about y equals -3, that's a horizontal line down here. So we would do washer method. So we would have pi integral from 0 to the 1.51097 of so a big R squared and a little r squared. All right, big R, start at your axis, go to the farthest away boundary, do top minus bottom. So the top function is actually your cosine, so it would be 4 cosine x minus -3 or plus 3. So that's your big R. Your little r, go to the nearer function, so it would be x minus 2 squared minus -3. For part B, we would do, so we have x equals 5. X equals 5 is over here. So we would do a shell method for that. And we'd have volume equals 2 pi integral 0 to 1.51097 of, and then let's see, our radius. So our axis is actually to the right of our region, so it'd be 5 minus x. And then our height is just top minus bottom, so it's 4 cosine x minus
Sayo Abdallah to Student Center East, Sayo Abdallah.
the x minus 2 quantity squared. And that's it.